All right, kiddos, we are back to finish up our first review, and I think all we have left are some dimensional analysis problems. We are going to convert within the metric system. We'll do some conversions from English to metric, and we're going to do some density problems. So that should finish up our first unit. Now, as you complete this review sheet, you should be working on this at home on your own, and then check the video to see if what you are doing is what I'm doing, and if so, you're doing it the right way. If not, you need to go back and review a bit more because you're not going to be ready for your exam. So let's start with some metric to metric conversions. So we're going to go with 16 milliliters to liters. So remember, to do these problems, we're going to start with what we know, 16 milliliters, kiddos. We're going to multiply by a conversion factor. Always include your units in these so we know what to get rid of and where to put it. So I have milliliters here, so don't I put that on the bottom to get rid of it. And I want to get into liters. So now we need to know the conversion factor here. Remember, milli means thousandth. And in this case, it means a thousandth of a liter. So how many milliliters are in a liter? That's right. If you said 1 liter has 1,000 milliliters, you are correct. The quantity on the bottom, 1,000 milliliters, is the same as the quantity on top, 1 liter. Now, since 1,000's on the bottom, folks, we're going to divide by it. So 16 divided by 1,000 is 0.016 liters. Okay, notice that milliliters canceled out, and we have the unit liters remaining. Okay, let's try 18.4 grams to milligrams. So 18.4 grams, we'll multiply by a conversion factor. Did you guys put grams on the bottom and milligrams on top? Because that's what I'd like to get into. So milli means thousandth. That means there's 1,000 milligrams in a gram. So this time, 1,000's on top, so we're going to multiply by it. So 18.4 times 1,000 is 18,400 milligrams, are the same as 18.4 grams. Now, on the next example, we have a prefix to a prefix. So if you recall, these take 2 steps. The first step will get you to the base unit, and the second step will get you to your desired unit. So we're going to start with 3,200 kilometers, and we'll multiply by a conversion factor. Put kilometers on the bottom and meters on top. That gets us to our base unit. Kilo means 1,000. So there are 1,000 meters in a kilometer. So after my first conversion factor, I'm in the unit meters. That's not where I want to stay. I want to get to centimeters. So I'm going to multiply by another conversion factor. We'll put centimeters on the bottom. Sorry, we will not put centimeters on the bottom. We will put meters on the bottom, won't we, to get out of them, and centimeters on top. So centi means hundredth. Have you memorized your metric prefixes yet? Did you know that centi means hundredth? So if it means hundredth, doesn't that mean there's 100 of them in a meter? So meters divide out. So I'm going to multiply by 1,000 and then by 100, and I will have my answer in centimeters. We can get our calculator out for this if you'd like. So we're going to take 3,200 and we're going to multiply it by 1,000. So we're going to scoot the decimal over 3 places to the right, essentially. And then we're going to multiply it by 100, so we're going to scoot it over 2 more places, and we end up with that big old number there. So let's write that in scientific form. 3.2 times 10 to the, let's see, 3, 6, I think that's 8. 3, 6, yep, I believe that's 8 centimeters. So we have 3, 4, 5, yep. So we have 3.2 times 10 to the 8th centimeters would be the same as 3,200 kilometers. All right, let's do 5.33 feet into inches. So now you can see we're dealing with English to metric. So let's start with what we know, 5.33 feet, and we'll go ahead and get out of feet. And I can get into inches first because I know how many inches there are in a foot. there are 12 inches in a foot. So feet divide out. And then I can get out of inches and into centimeters, because I know this conversion factor. There are 2.54 centimeters in 1 inch. So now inches are gone and I'm in centimeters. And finally, to get into meters, we're going to put centimeters on the bottom, meters on top. Remember from the last one, there are 100 centimeters in a meter. So centimeters divide out, and we'll have our answer in meters. So let's see what we get. 5.33 times 12 times 2.54. And we're going to divide by 100. It's on the bottom there, kiddos. And we get 1.624584. We get all those numbers. So let's see how many sig figs we're allowed. Definition, right here, this has 3 sig figs. That's a definition. This has 3 sig figs. So my answer can have 3 sig figs. So I'm going to round that off to 1.62 meters. Okay? All right, next up, letter E. Find the volume of a rectangular solid. So I give you the length, width, and height. So volume is going to be the product of those three. So 3.77 centimeters times 4.42 centimeters times 6.99 centimeters. And let's see what we end up with here, folks. 3.77 times 4.42 times 6.99 equals, boy, that's a big ugly number. Let's see, we're allowed 3 significant figures because I have 3 here, and 3 there. So I'm going to round that off to 116. And we have centimeters times centimeters times centimeters, so that would be 116 cubic centimeters for my volume. Okay? All right, now, if the object above has a mass of 223.63 grams, what is its density? So density, as you recall, is mass divided by the volume. And we like the mass in grams and the volume in cubic centimeters, so this will work out quite nicely for me. My mass is 223.63 grams, and we'll divide it by our volume, 116 cubic centimeters. So our unit will be grams over cubic centimeters. And let's see when we do the math what we get. 223.63 divided by 116. And we end up with 1.9278. We're allowed 3 significant figures, so we're going to go 1.93 grams per cubic centimeter. Is that what you got for your density? Would that sink or would that float in water? Yeah, the density is greater than the density of water, which is 1 gram per cubic centimeter, so this would sink in water. All right, let's continue on with this same object. What if I had 42 cubic centimeters of the object? What would its mass be? So we have 42 cubic centimeters. Now this is where we're going to use density as a conversion factor. We're going to get out of cubic centimeters. We'll put that on the bottom. We want to get mass, so we want to get into grams. Now, my density is 1.93 grams per cubic centimeter. So I can use that as a conversion factor. 1.93 grams per cubic centimeter. So cubic centimeters divide out, and we'll know the mass of our object in grams. So let's see what that turns out to be. 42 times 1.93. We're only allowed 2 significant figures here, so I'm going to round that off to 81 grams. Okay, 2 significant figures, because this has 3, this measurement has 2, so I have to go with the lowest, which is 2 sig figs. All right, letter H. What would the volume of 34.98 grams of the object be? So 34.98 grams. Okay, we're going to put grams on the bottom this time to divide out of it, and we're going to get into cubic centimeters volume. So we're going to use our density as a conversion factor again, 1.93 grams. So let's put the 1.93 by the grams per cubic centimeter. So this time, grams divide out, and we'll end up with cubic centimeters. So let's see, 34.98 divided by 1.93 this time. 34.98 divided by 1.93 gives me 18.124. Looks like we're allowed 3 significant figures, so we're going to go 18.1 cubic centimeters. Okay. All right, one more problem on this review. So let's see what we have here. We have an object. We know its mass, 75.83 grams. We place it in a graduated cylinder that starts out with 49.3 mils of water. And after the object is placed in there, the volume rises to 62.5 mils. So maybe we can draw a picture of that. Here's my graduated cylinder. You folks probably remember doing this in the lab. We have some water in there, and it looks like we start out at 49.3 milliliters. And then kerplunk, in goes my object. We'll make it a irregular shaped object. Does that look irregular to you? And the water level goes up to 62.5 milliliters. So the volume of the object is how much water it displaced. So let's see. Let's find the difference here. 5 minus 3 is 2. 12 minus 9. That's 3. Had to borrow 1. Okay, so 13.2 mils would be the volume of my object. Now I'm subtracting here, kiddos, and when I subtract, I look at decimal places when I round off my answer. So this is to the nearest tenth, this is to the nearest tenth, so my answer can be to the nearest tenth. So 13.2 milliliters would be the volume of my object. Now to find the density, you'll remember, is mass divided by volume. So my mass is 75.83 grams. My volume, I just found, was 13.2 milliliters. And so we should be able to figure out our density in grams per milliliter. So let's plug that in and see what we get. 75.83 divided by 13.2, and we end up with 5.7446. We have 3 significant figures here, 4 significant figures here. We can have 3 in my answer, so I'm going to count over 3. 1, 2, 3. 5.74 would be the density. Grams per mil. Okay? All right, that wraps up our Unit 1 review, kiddos. If you could do everything from these past 2 review videos, you should be ready for your exam. If you can't, you need to work on a few things. So get that squared away before our first exam. All right. Nice working with you. Talk to you later. Bye-bye.